We've talked now about how functions are continuous, and we mentioned briefly before that we could draw functions that are discontinuous, that are disconnected. And down below here, you'll see underneath our types of discontinuities that there are several different ways that a function could not be connected. We have three really different categories of discontinuities. We have what we call removable discontinuities. This is where in the graph I would have something like a hole, or I would have a hole maybe with a point somewhere else above or below it. I have infinite discontinuities, which is where the graph gets disconnected, maybe based off of some sort of vertical asymptote. Notice though here in this picture, it is still possible to have a dot or a point on the graph that's on my vertical asymptote. There's nothing wrong with that. It would just have to be a piecewise defined function. I also have jump discontinuities, which is where my graph is kind of composed into different pieces that all separate from one another. And we saw something like that in the sample picture that we had in example number 3, and we drew some pictures like that in the opening motivation. So understanding these different types of discontinuities can be important, and recognizing when you're dealing with each type of one is sometimes relevant. So let's take a look here at example number 4. We want to find all the real numbers at which the following function, h of x, is discontinuous. And we also want to state the type of discontinuity, like is it removable, is it infinite, or is it a jump, at each of these numbers where the graph's discontinuous. All right, so at the moment, we don't really have a great way to check for discontinuities. At least, we don't have really an efficient way, but we'll develop one of those in a little bit. What we're going to start with here is to just think about, again, this kind of intuitive idea of what's going to be happening with our picture. So let's go ahead and try to quickly create a graph of what h of x might actually look like here. So if I was to go ahead and draw out a picture of h of x, I can see that whenever x is less than the value of 2, I'm going to have y equals x as the graph that I'm using. So notice if I was to plug 2 in for here, I would get 2, 2, and I would have a hole there. And then the graph y equals x would kind of stretch backwards. So I'd have a picture that looks like this. Okay? Now notice this portion of the picture is going to just be a nice straight line that's kind of going to be all connected, kind of like from 2 backwards. It's all connected. Now let's see where this other portion of the graph is. This is x minus 2. Well, if I plug 2 into here, I know I would get a hole, or sorry, a point on the graph, and it looks like if 2 plugs in, I get 0. So I'm going to have a point here on the graph, and then I know that it's again equation of a line that's just going to step up 1 over 1, up 1 over 1. And so I'm going to get some sort of a picture that is again going to look something kind of like this. Okay? So again, this is just a rough sketch of what the picture of h of x is going to look like. Now what I can see here is that again, my graph has 2 different pieces in it, and it looks like each piece by itself appears to be all connected and continuous. So I can say here the following. I'll state that we see intuitively from the graph that the only discontinuity, the only spot where this graph breaks apart, is at what x value? Well, it's at the x value of 2. So the only discontinuity is at x equals 2. Okay, and now the problem said to kind of classify what type of discontinuity is it? Is it removable, where there's kind of a hole and the graph keeps going around it, maybe a dot above or below? Is it infinite, vertical asymptote? Or is it a jump, where I have different pieces that are separated out? Well, in this case, it looks like this is a jump discontinuity. This is a jump discontinuity. So hopefully this gives you a good idea of the different types of discontinuities that we're going to be working with. And in the next example, I'll ask you to try to think about some different sorts of graphs that might have other types of discontinuities in them.